Hello everyone, this video is about the auxiliary angle method. So we can express a sine theta plus b cos theta in the form r sine alpha theta plus minus alpha or r cos theta plus minus alpha. So we have these shortcut formulas if you wanna use it, or we can just expand using the compound angle formulas and then identify r sine alpha, r cos alpha, and then we divide to get the alpha, and we use Pythagorean identity to get the r. For example, we have 2 sine x, so we have 2 sine x plus 2 root 3 cos x, and this is equal to, so we use the sine compound angle and we multiply by r, so we have r sine x sine cos plus cos sine, and now we identify the r cos alpha, so it's supposed to be 2 because sine x, so the coefficient is 2 on the left, on the right the coefficient is r cos alpha, so we have r cos alpha equals 2, and we do the same thing with the 2 root 3 on the left and r sine on the right, so we have r sine alpha equals 2 root 3. So to find the alpha, we can just divide both sides, so we have the red divided the yellow divided by the red, so we just divide. Yeah. So if we divide the two equations, of course we can cancel out the r, so we have only tangent alpha equals root 3. Yeah, of course alpha is therefore inverse tangent root 3, which is 60 degrees. And to find the value of r, we can use the Pythagorean formula. So if we just square r sine alpha, so we square r sine alpha and we also square r cos alpha, we square this and we square this, it's supposed to be equal to the square of 2 root 3, the square of 2, we square again, so we square, and we get r squared sine squared alpha plus r squared cos squared alpha equals, we can use your calculator here, 4 times 3 12 plus 4 16, and we can factor out the r squared times sine squared plus cos squared, which is of course 1, so basically r squared equals 16, and we are using the positive value of r equals 4. So if you use negative value and you plug in back, you'll get something that doesn't add up here, so you have to use the positive r and you have to use the quadrant 1 60 degrees. That's it. So in conclusion, we can express this as 4 sine x plus 60 degrees, and we can do the same thing here, but this time we are using exactly the same. 2 sine x, 2 root 3 cos x, 2 sine x, also 2 root 3 cos x, but this time we use our cos x minus alpha. So we're not using our sine, but we're using our cos. So yep, let's just use green first again. So we have 2 sine x plus 2 root 3 cos x equals r cos compound angle. So cos plus sine and now we identify the r cos alpha is 2, so we have r cos alpha equals 2 and r sine alpha equals 2 root 3. R sine alpha equals 2 root 3, and then we can just divide the two equations and we get just tangent alpha, because you can cancel out the r, so we have only tangent alpha equals root 3, and therefore the alpha is again 60 degrees. And exactly the same. Alright, now we wait a minute, something's wrong here. Okay, actually for the cos it's actually 2 root 3. Alright, wrong color for the cos. Okay, so for the cos the coefficient is actually 2 root 3, because for cos x it's actually 2 root 3, and for the sine it's okay, so it's 2 root 3 here and just 2 here. Okay, it's just 2 and this is 2 root 3, so it's actually 1 over root 3, 1 over root 3, and if we use inverse tangent we get 30 degrees. And then we square again, so it's r squared equals, we just square the 2 root 3 and the 2, so just like what we did before here, but we do it faster, and we get r equals yeah, that's also 16, so it's also 4. So in conclusion we have r cos x minus 30 degrees. So if we use sine plus we get this form. If we use cos minus we use this form. In case you're wondering, if we just draw the y equals sine x and the y equals cos x, we have these two graphs. Of course the sine x is actually just like cos, but we move it 90 degrees to the right, so x minus 90 degrees. And cos x is just like sine, but we move it 90 degrees to the left, so to the left means plus transformation, so which means sine x plus 60 degrees, we replace the x here with x plus 60 degrees, so this x is replaced with x plus 60 degrees, and we get x plus 60 minus 90, so x minus 30 degrees. So it makes sense. Or we can replace this x with x minus 30 degrees, x minus 30 degrees, and we get x plus 60 degrees. Again, everything makes sense. So we use this auxiliary method to maybe find a maximum or a minimum value of this expression.